Okay, so right now we'll be doing number patterns. So number patterns, right? You need to understand my lingo when I first say first layer constant difference. Okay, so today I'm not sure where you can focus everything, but let's focus on first layer constant difference first. So now take out your notes right now and write it down that whenever we want to do number patterns, before we start, we must always draw skeleton.
Draw sentence.
Draw skeleton.
Oh.
And what is draw skeleton? Draw skeleton meaning to say that here can either be the figure, and here is the answer. Either figure or term number, they are interchangeable. So either figure or term number, and usually this is referring to your n value or the nth term. So whatever I write on the screen, write it down now.
Okay.
Done?
Yep.
Yeah. So right now, what is this first layer constant difference? So this first layer constant difference can only be found out if and only when you draw the skeleton. Okay? So what is this skeleton? So can you see here? They say first layer of constant difference is yes, right? There are actually two types. Today, we're going to focus more on the first type, that is the plus minus type. What do I mean by plus minus? For example, you know, sometimes you see this, the question give you in this format. They tell you that it's 7 followed by 12, 17, 22, 27, and so on and so forth, correct? Hello, are you there?
Yes.
Okay, so right now,
Yep.
usually whenever is this, right, the very first step is, remember I told you to draw the skeleton. So for me, I always like to write either the figure and then the answer. Meaning to say, what is the figure? This is the first term. Can you see the first term? I put 1 and the answer is 7. This is the second term, 2. The answer is 12. Third term, 3, and the answer is 17. Fourth term, 4, and the answer is 22. And the fifth term, 5, and the answer is 27. And so on and so forth. Got it?
Yep.
Okay, write it down. Let me know when you're done.
Okay. Okay, done.
Okay, so now whenever we do anything, we must always ask ourselves, how do we get from 7 to 12? Is it getting bigger or getting smaller?
Getting bigger.
So I want you to find a corner, maybe on the bottom, the top, top right or top left. Then you write it down. Whenever it's bigger, we will look at signs like plus or times. Whenever it's like smaller, when it's getting smaller, we look at sign like minus or divide. Understand?
Yep.
So let's look from 7 to 12. What do you think? What sign do you use?
Plus.
Plus how much?
Plus 5.
Okay, let's see whether the next one is also like that. 12 to 17.
Plus 5.
17 to 22.
Plus 5.
22 to 27.
Plus 5.
Perfect. So we realize that, this is perfect for me. Can you see here? That's why I say plus or minus. It can be like maybe a plus 5, like example, constant difference, it will be like plus 5. Or like minus 5. Or like plus 2. Minus 2. Understand? These are all called constant difference. So I put it in blue color. So this is my constant difference. So this is in blue, right? So can you see these are all in blue, 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 correct?
Yep.
So you can see this is the formula A plus D bracket N minus 1. This D right here is your constant difference.
Oh.
You also put it in blue. Done?
Yep.
Next, what is this A? This A means your starting number. Starting number. And what do you start off with?
The first term.
Yeah, what do you start off with? What's the number you start off with?
7.
So my starting number is 7. Can you see that? And I highlight this in pink. Are you following it? Are you also highlighting it in pink?
Yes.
Okay, N will just stay as N. So now, you know, sometimes the question will ask you to find out what, like the formula or find out the nth term, correct?
Yeah.
So your question, let's say your teacher say, hey, find the nth term for this sequence. Wait, my pen has issue writing. Okay, they say find the nth term for this sequence, right? So how to do? Can you see here? The nth term means Tn. Understand or not?
Mm-hmm.
A means 7, so I put in 7. Plus D is 5, so I put plus 5. Understand?
Yeah.
The D is minus 2, then I put minus 2. Clear so far?
Wait, but why minus 2?
If the question, the
Oh.
D is minus 2, but for this case, it's not minus 2, it's plus 5.
Oh, okay.
Meaning to say that it's sign sensitive. It can be a plus, it can be a minus. Understand?
Okay.
This part here is sign sensitive. It can be a plus, it can be a minus, depending on the situation. Okay?
Okay.
So it's plus 5, and what's the N? The N will just be N minus 1. Then now you just write as Tn, you just do your algebraic expansion, draw rainbow, expand it out. So it'll be 7 plus 5n minus 5. So Tn, the formula for this will just be 7 minus 5 is 2.
3. Oh, 2.
2.
Yeah, 2.
2 plus 5n, and that is the answer. The
Oh.
answer is this.
Okay.
So copy everything down now. Remember to color code. Literally, whatever you see on the screen, I give you some time to copy while pause the recording.
Okay.
So just now we did plus, right? Or minus, right? I never really do minus with you, but it's the same case. So right now, it's a first layer constant difference again, but right now it's a times. Understand? So times, you must be good in your indices. So right now we're going to zoom into this part called times. So what does time means? Means that you take A, and A is the same thing. Just now I use starting number, what color?
Wait.
What color did I use just now? You
Wait.
must follow the same color coding.
Wait. A for wait, then D is blue.
What color did I use for A?
Red.
No, I didn't use red for A.
Hey, you.
What color did I
Why
use?
what?
What?
The A is red, then the D is blue.
No, the starting number I use pink.
Oh. Okay.
Okay, so remember, the very first step is you must always write down the figure number first.
Yes.
And the answer, meaning to say that you need to draw the skeleton, right?
Yep.
Because all these are not in the format of a skeleton. So tell me what to fill in.
Fig 1 is 3. Then fig 2 is 6. Fig 3 is 12. Fig 4 is 24. And fig 5 is 48.
Now, we need to ask ourselves, how do you go from 3 to 6?
Times 2.
And let's see, 6 to 12.
Times 2.
12 to 24.
Times 2.
24 to 48.
Times 2.
So can you see everything is all times 2 times 2 times 2. First layer constant difference, correct or not?
Yeah.
Which is here, this is first layer constant difference, which is this blue. So that's why I highlight this in blue also. Means the constant difference is 2. And then next, A is the same thing, is the starting number. So I highlight this in pink. So how do we fill in this and this? Same thing. N term means T small n. Equal to what is A? A is 3. So let's put 3. They never write anything means times. And D is 2 to the power of n minus 1. And that's the answer. For the n term.
Okay.
So don't forget to copy all this into your notes. So the next one doesn't have first layer constant difference. The next one is second layer, okay? So let's say first layer constant difference don't have, then we move on to the second layer constant difference. Now, this one is more complex. So you can memorize this formula. This is also the same thing. A is the starting number. You can highlight that in pink. Starting number. Okay. D1 means the first layer of constant difference. Then D2 is second layer constant difference. Okay, let's say your algebra is not good, then you can memorize instead of n minus 1, n minus 2. Okay, I teach you the algebra. How do you expand this out? You do upper rainbow and lower rainbow. Upper rainbow, upper rainbow. N times n, n squared.
N squared.
N times 2 minus 2n.
Yes.
Lower rainbow minus n. And lower rainbow plus 2. Simplify it, means you get n squared minus 3n plus 2. So let's say you feel that this is harder to memorize. You don't need to memorize this. You can memorize this thing as n squared minus 3n plus 2. Just that when you memorize, you need to be very careful of the plus and the minus sign.
Mm-hmm.
Sorry?
Okay.
Same thing. Whenever we do this, we always need to go and draw the skeleton. Okay, I want you to draw now and then check whether your answer is the same as mine.
Okay. Okay, correct.
Now, you'll find first layer, right?
Yeah.
Here to here. What happens?
-4.
-4. Next one, here to here.
-6.
Next one, here to here.
-8.
Here to here.
-10.
So can you see there's nothing the same? Constant difference means there's the same, right?
Yeah.
Anything?
No.
Then we go one more layer. Meaning to say, -4, how to get to -6?
-2.
-6, how to get to -8?
-2.
And -8 to -10.
-2.
Okay. So right now, you can see, right? So these are all minus. Then you realize that, on the second layer, I had everything constant already. They're all -2, -2, -2. Then I can kind of stop, correct? Not?
Yes.
So what's the starting number? The starting number is 56. Is this A? What is the first layer constant difference? -4. Means this D1 right here is -4. Then what's the second layer constant difference? Means this D2 here is -2. You understand?
Yes.
So right now, I don't know whether I have a post-it. I want you to take out a post-it and let's start applying this formula.
Sure.
You have a post-it.
I don't have. Wait, I can't have.
Okay, go and take a post-it right now. I want you to put it in the formula and check whether your algebra is the same as mine. Okay, so I'm going to pause the recording. You can start doing. Then you can check whether the answer is the same as mine.
We are going to take post-it.
Okay.
But my first time I do, I almost got correct because I got like 50.
Do you explain carefully? First thing first is, do you have exactly what I have? The one that I boxed out in green.
Yeah.
Then follow the steps and see whether is it the same.
-1. 6.
Check for your expansion. Check for your positive and negative numbers.
Oh. Yeah, maybe I did it wrongly. Oh, okay, I got it now.